Okay, this is TempleOS 5-minute random code walkthrough episode 85, and I'm your host, Terry Davis. And today we are in the Red C file system, Red C drive validate. Okay, so Red C drive validate drive letter. Okay. Where do we call this? Find. This is find Red C validate. This might work. Okay, it's an extern. It's in disk 1. Block device init. Okay, now I know what this is. So believe it or not, you can I have a RAM disk that's drive letter B, and you can boot if you it's really hard to do, but even what this is doing is you can do a soft boot. That's easy to do. So here's what I'm talking about. On my menu, I have RAM boot. If you look at the code for RAM boot, RAM reboot, you give it a file name of the kernel, then it loads it into memory and jumps to the it's not in okay, my kernel starts in real mode normally, but if you want to reboot and start well, it can't go back to real mode, so it goes to just after real mode. Anyway, long story short, you can reboot a kernel.bin file, and that's no big deal. But if the RAM drive is located in the same spot, then when it validates, it will not reformat at boot time. So you can store files on the RAM disk and reboot. If you reboot with RAM reboot, and the RAM drive will stay intact even when you reboot. Now, if in theory you can even recompile the kernel on a RAM drive and then boot a new kernel on a RAM drive. So for example, let's say you had a new computer. I made well, if you had a new computer and the hard drive wasn't working, you could recompile the kernel in RAM and reboot, so you didn't have to reburn a CD-ROM. Anyway, I guess it's... So let's go back to see what it does. Letter to drive. Okay, well that just points us to the right structure. I think it might check for if we enter an invalid, it does a drive check, which checks the signature. So if the signature is not correct, or if the type is not Red C, and it reads a block, it reads the first block, which is the partition boot record. It checks for Red C signature. So the main use of validate is for when you reboot and you want to use your RAM drive. Honestly, I've never used it. I don't know why I make a big deal of it. It's just cool. You can put files on the RAM disk and reboot, and as long as you keep the same memory configuration, the RAM disk is loaded off of malloc. Or when you recompile, you can specify where the RAM disk is. That gets trickier. I made a rescue disk that what it does is you put some files. I put some files onto my RAM drive. I make a RAM drive at so my kernel goes from 7C, this is in the lowest 640, 7C to 3.5. So I can make a RAM disk. As a matter of fact, I can do that. Let's see. So 3.5. How about 35400? So 35400. So the maximum is about. There's some stuff that you run into. Let's just go to 9. Let's see. There's 726 blocks. So if I say mount, and I can make a RAM disk, first drive letter A, B, how about A? And we'll call it a RAM disk. Address of RAM disk. Okay, we'll say 35400. Now, as long as we keep the kernel the same, this RAM disk will stay intact. I happen to know this is a gap that does not get allocated. This location does not get it. It doesn't get messed with. So I just made a RAM disk down there. Then I could copy files. So what I do here is I wonder if I make the boot fig. I make the rescue drive. Where do I? Okay, the rescue drive. Oh, well, how do I do that? I think okay, well, I make the rescue drive. I put it down there, and then I try and copy as much as possible into the low 640. The low 640 is, my operating system is too big for 640. But the main thing you want is the compiler, and you know, this file that I'm looking at right here, it's on, you can look at my startup code and some of my personal code. It's in the demo directory under account example. And what we're looking at right here is in the distro rescue. So we're looking at, you can look at this code, it's on the standard distribution. So this makes a rescue disk. So once I copy, I'm confused. There's more to it. Okay, I make a file that stores, I take the whole RAM drive image and I store it in a file. And then you know what I do? Okay, so I store it in a file. What's the name of that file, by the way? We can't, we're having problems here. Okay. Well, that's another bug. Anyway, I know what I do. In my kernel, right after kernel end, I put the, I make a command to load a bin file. Okay, so I set an option for a boot rescue disk, and then this will inject a bin file, that's just raw data, into the kernel. So the kernel will be bigger and it'll be loaded by the bootloader. And as long as I set the rescue disk, as long as I have as long as I define the rescue disk, oh, it has to know about the compiler, doesn't it? It has to know what disk it's on. So I do believe the kernel, when it loads the compiler, oh, the default disk is the boot disk. No, the default disk is the, so the startup disk is the, if you tell it to make a rescue disk and put it in a low 640, then when it starts up, I think it, look right there, boot rescue disk. No, that's not it. Anyway, it, oh, you make it boot that disk as the default. You tell it to boot the A as the default. Anyway, okay, well.